Hello everybody. In this lecture series, I'm going to talk you through how I go about sifting through the various chain ladder models available to me to make a final ultimate selection for each origin period for a segment. If you followed my advice from previous lectures, you should have ended up with a range of reliable chain ladder models for each segment. You would have modelled closed and reported claim numbers, average costs, paid and incurred, etc. You would have saved down various models for each of these data elements to test your assumption choices. We now need to bring these all together into a single ultimate view for each origin period in our modelled segment. Don't get me wrong, ranges and communicating uncertainty are important for actuaries, but we do need a single ultimate to book in our reporting accounts and in our management information, and also to feed into our pricing models. In this first video, I'll talk through how I go about the iterative process of making draft selections, reviewing draft results, and then adjusting where necessary. I'll also talk about how I assess where chain ladder models are not sufficiently reliable to help me, and so I need to either fix my draft ultimates or use alternative methods to get to a final result that is reliable and justifiable. Let's start with the checklist. Selecting your draft results is an iterative process where you will make an initial decision at step 1, allocating weights between your available models, then go through the next 4 checking systematically whether the draft results look reasonable. You'll recognise these 4 steps from the previous lecture, but now we're looking at lots of data against lots of models rather than purely modelled data against modelled results. If the draft result passes all the tests and you're happy, put it down and move on to the, I promise, final stage of the process, which is covered in the next video. If you aren't happy, then you head back to step 1 to refine your selections based on what you've learned from steps and go through the various steps again. In my experience, a lot of junior actuaries skip this step, do some basic models and clash them together without thinking whether the results look reasonable or not. Believe me, it's easy to spot when that's happened, and as a reviewer, I'd be immediately concerned. So, do things properly, and confidence will grow in your work, as well as giving you reliable, justifiable results. Let's start with step 1. This exhibit is showing me each of the chain ladder models I've saved down, and is comparing the results for each origin period against the modelled data, in this case closed and reported claim numbers. This is where I'll need to choose how much weight to give each of my candidate chain ladder models when selecting my draft results. Essentially, this is a table full of numbers, so it is a little hard to interpret, but I can immediately see that I have 3 candidate closed models and 3 candidate reported models to choose from. I've labelled them well, so I've got a prudent, an optimistic, 2 objective volume all, and 2 subjective volume 4 models to choose from. Looking at the total results, I can see that my prudent run is giving me the highest ultimate and the optimistic run is giving me the lowest ultimate. So I've got a funnel of uncertainty to work within. And all 6 models are giving results around about 20% of each other. So this isn't a super tricky class, and I should be able to come up with a reasonable draft selection here. So how do I allocate weightings between these 6 models to get a set of draft results? So let's look at some charts of these numbers. As usual, a picture paints 1,000 words, and so it can help us cut through detail and see more clearly what's going on. This exhibit is a chart showing us a line for each of the ultimates from the various chain ladder models we have available for this segment. It's essentially the table in chart form. I can see that the ultimate levels are broadly constant over origin periods, which is a good sign for using chain ladder models. We can quickly assess that we have a strong alignment between the models up to around about 2016. And if we ignore the prudent and the optimistic models, then we have pretty strong alignment all the way to 2019. This is good and reassuring. Let's look at an example result selection, which is giving us a more troubling pattern. This exhibit is showing us the same information, but for a segment where we discrepancy between closed and reported models. The closed models have dotted lines and look consistently lower than the reported models, which have solid lines. When I see this, and it's not uncommon, then there are two possible causes. Firstly, there is a distortion in the policy life cycle, causing closed and reported, or it could be paid and incurred, claims to not trend to the same ultimate position. Now we know that when the policy life cycle is complete, all reported claims are closed and all incurred claims are paid. So these two data triangles must end at the same ultimate position. And so where things seem out of line, then we need to be communicating this to the claims team more widely. However, before I go outside of our team, I'd want to satisfy myself that the second cause is not at fault, and that is that we've messed up the modelling of one or other element. Have we missed a changing trend in our modelling that could be by reparameterising or resegmenting? For example, are the closed claims much more longer tail than reported, and we've had to fit a curve or a tail factor? We need to fully demonstrate that both sets of models are appropriate and then reappraise our draft results. Let's go back to our original example and carry on with the checking steps. This is our original Exhibit 2, but just showing the closed claims for the model, for the segment. So again, we're pretty aligned up to 2016, and if we ignore our red prudent model, then we're pretty aligned all the way up to 2019. So from this exhibit, I might consider including a closed claim model in my draft selection all the way up to 2019, possibly even 2020. Now, candidate reported models for this segment. Here we're pretty aligned up to 2017, and if we ignore our optimistic model, then we're well aligned all the way up to 2020. So I should be confident including a reported in my draft selection for all origin periods. So now let's allocate weightings between our 6 chain ladder models to get a set of draft results. I would normally start by picking one model for each data triangle modelled, in this case one closed and one reported model. I would usually want to give equal weight to each model chosen. I start with the models in the middle, so not picking the prudent or optimistic candidates. I'd want to refer back to my modelling notes to see if there is any steer in them, for example a major change in mix or growth in the account or a change in the claim department's case reserving process that might push me towards a shorter average of historical data. I also want to avoid a major discrepancy between calibration of the chosen models. So for example, not picking volume all for one data triangle and volume 1 for another. For this specific example, we've looked at the absolute results. It looks like I should have confidence in my reported models for all periods, and my closed model is up to 2016 or possibly up to 2019. In this example, I can see that my volume 4 models seem to fit all these characteristics and give results that aren't extreme, and so can be used for my first iteration through the checklist. One last thing, chain ladder models work well on data that is stable and not immature. As a rule of thumb, if a model is less than 50% developed, then it might not be reliable. I can see here that my closed data, are not well developed in the 2018 to 2020 origin periods, and so I'll just use the reported model for these in this first iteration of my draft results. So on screen we can see I've made those selections, being 50-50 weight to closed and reported up to 2017, and then excluding the closed model for the last 3 years as it may be insufficiently developed to be reliable. In this case, my reported model is pretty mature for all origin periods, but that's not always true, and maybe not in this example true for 2020. If I had no mature dataset for an origin period, then I would still pick a reported model to enable me to go through the 4 checking steps, but I'm expecting to conclude that we need to fix or use another method for those more recent origin periods. We'll see how 2020 looks in our test now. We can see that there's not a difference in totality between our chosen closed and our chosen reported models, 1927 versus 1887, which is reassuring. I can now do some quick checks on the draft results in advance of the 4 checking steps. I can see which origin periods have completed their journey through the policy life cycle and so have 0 claims. We can see that applies for 2011 and 2012, and that 2013 and 14 aren't far off either. This means we should have a fairly solid base for our projections, and we shouldn't have faced the relatively tricky task of setting tail factors. I can also check that my open claim numbers are always positive. If not, we've probably got a data error and need to fix or justify that issue before we proceed with our modelling. I can also check that there's no IPNR placed on those completed origin periods. This is a standard check on modelled ultimates, so it's good to see that we'd pass that test here with no IPNR on origin years which have 0 outstanding. Note that we do have some small negative IPNRs, but as discussed, it's fine, providing it's a genuine trend and we're modelling reported excluding nils. We also don't have any negative future numbers, which would have been much less fine, as it would have implied that we were going to reopen claims which had settled at cost and then resettle them at nil. I can also see that my IBNR to open ratio is higher in recent origin periods and generally increases over time. This is the trend we'd expect, since more claims would have completed the policy life cycle over time, and so the potential for future development should reduce. Finally, I can see that my reserves, numbers here, increase over origin periods, which again is what we'd expect to see. This is our original Exhibit 2 again, but now just showing the selected, closed and reported models for this. We can see that our two candidate models are well aligned up to 2019, which gives us high confidence in our draft results. It only looks like 2020 might be tricky to assess. This is our original Exhibit 2, but now just showing our draft results, formed by averaging the selected, closed and reported models for this segment. We can see that this all looks good. Maybe a little bit of volatility in 19 and 20. It can be easier to assess trends though when we standardise our results by looking at our ultimates divided by closure measures. So let's do that now. We're now looking at a standardised version of our draft results, so we can really tell if our results are consistent over origin periods. Here we are looking at claim frequency, which is ultimate numbers divided by policy count. It's fair to say that this exhibit looks very stable on a standardised basis, with the possible exception of 2020, which is maybe a tiny bit high. We need to consult back to our modelling notes to see if an increase in frequency was expected in 2020. We may tentatively decide that there is only a small deviation from normal levels, and that this is acceptable. The financial significance of this assumption is important here, i.e., is this a big class or not? We should focus our subjective thinking and our time on areas of much significance and not micromanage each last pound of ultimate. So, to tick off the various checks here, it's good, we're not seeing any trend in our standardised with frequency levels being very stable over all origin periods. We're seeing a frequency of 14 to 16%, which doesn't sound an unreasonable level, so again passing our checks. We're looking at origin years here, so do be careful allowing for seasonality if you're looking at monthly or quarterly origin periods. Move on to the next checking step. I've switched to a different data set for this next exhibit, as I want to draw out some interesting features, which wouldn't be in the closed reported example we were just looking at. This exhibit is showing us incurred development for each origin year as a percentage of our draft ultimate. This draft ultimate is chosen from an average of both a paid and an incurred chain ladder model. So although it looks like the all origin charts we've considered when doing our incurred chain ladder model, it's actually a lot more insightful than those. The first thing to note is that our incurred claims still look like they are trending to ultimate, which means that we must have alignment between our paid and incurred chain ladder models, which is very reassuring. Remember, by modelling two separate data triangles which must end up at the same ultimate position, in this example paid and incurred, we get 2 bites at the cherry to get the ultimate correct, as looks like here. And we also get to find out when those two views are misaligned. In that case, we need to ensure our chain ladder models are well calibrated, and we've allowed for any changes in mix or other known distortions to the policy life cycle. If after that the misalignment remains, we need to loop back to the claims team to inform them of an unknown distortion in the policy life cycle. It could be that there are redundant outstandings, a processing backlog, or a change in claim handling processes, all of which are valuable insights to optimise our claim handling and reserving processes. What we can see here though is that development is very tight after about 4 years, but quite erratic before that point. This reduces our confidence in the ultimates from our incurred chain ladder model for the first 3 origin years. We may choose to adjust our weightings between paid and incurred models, and/or we may decide that the chain ladder model is not reliable for these recent years, and instead we need to fix or use alternative methods which are less development based. We can also see that the incurred development is probably less than 50% in the first few development years, and so again we may decide that our incurred model is not mature enough, and so lean further towards fixing or using alternative methods. Note that when we adjust weightings with methods, we need to be careful of 2 things. Firstly, we do not want patchwork quilt selections where we constantly vary our weightings between candidate models from one origin period to the next. This is likely to be overfitting, hard to justify, and just a lot more time consuming than picking a more elegant solution. Secondly, it's okay to models completely as they get too immature, but generally sticking with a constant 1-1, 2-1, or in the extreme 3-1 weighting for all origin periods avoids spurious accuracy. I would generally always start with a 1-1 ratio between paid and incurred models, but as you gain or lose confidence in one or the other model, you can shift to a 2-1 weighting. Just avoid anything over the top such as a 5-3 or a 6-1 weighting, as it just looks like overfitting to anyone reviewing your work. Let's switch over and look at the paid development now. This exhibit is showing us paid development for each origin year as a percentage of our draft ultimate. As a reminder, this draft ultimate is an average of both a paid and an incurred chain ladder model, so it's really insightful in a number of ways. As per the incurred chart, again here there is a reasonable trend towards ultimate shown by the paid development. But when modelling, I would have been concerned that the paid development was still strong in the later periods, and so a tail factor might have been required. However, the fact that both paid and incurred models head to the same ultimate reassures me that a tail factor isn't required, and that perhaps the kick up in the 10th development year is actually a blip, maybe from a small old origin period, which should not be taken as part of the true but unknown underlying development pattern. I can also see that my paid development is very long-tailed, but also very consistent. This is a common feature and leads me to an important debate I often have with junior and some senior actuaries. There is a natural tendency for actuaries to overweight their incurred models in their selection. The argument being that incurred claims contain more information, everything paid, plus case estimates, that they are closer to ultimate and hence more reliable. However, it is often that additional information, those case estimates, which can be to the detriment of the incurred claims data. The reason being that those are subjective values, subject to change in processes and or claims department personnel and or backlogs and shocks. So those case estimates can be very variable and hence less reliable. On the other hand, your pay claims are much harder to distort. If I've crashed my car or my house has been damaged, then I want my claim paid and my car back on the road, or the hole in my roof fixed. So for classes with lots of policies and claims, the paid amounts come in with a steady, unwavering tempo that is very easy for the chain ladder model to latch onto and reproduce, giving steady, reliable ultimate projections. Why wouldn't we want to benefit from stability and use our paid chain ladder models as much as our shorter-tailed but less stable incurred chain ladder models? This exhibit is showing us exactly that feature. Some actuaries would immediately dump this paid model as too long-tailed, but just look at how tight that long-tail development is. So the true but underlying development pattern. It's far more stable than incurred, particularly in the first few development years. So this is an example where I'd probably want to give more weight to paid than I had originally done, due to its long-tail nature. And in the extreme, this might prevent us needing to fix or use an alternative method at all for those recent years. Let's go back to our closed and reported example and look at the last step in our checking process. This exhibit is showing us absolute closed and reported development for a single origin year, 2015, against our draft ultimate numbers. We would naturally want to look at a chart like this for each origin year when carrying out our checking. What we're looking for is whether both the closed and reported claims are trending towards our ultimate position. In this example, I would say yes, that does look the case, with both closed and reported being quite developed and close to the ultimate position. It can often be particularly telling to see how the closed claims are developing towards a draft ultimate based on reported claims chain ladder model and vice versa. We can also check visually whether the ultimate is set at about the right level. Is it way above our reported value, suggesting unreasonably high IBNR? Or is it below our closed claims, implying we are going to reopen and settle claims nil, which would be very unlikely to happen? In such cases, we would need to reassess our selections between our candidate closed and reported chain ladder models and repeat the checking steps again. Anyway, this model looks fine, so it gets a clear pass for the 2015 origin year for me. Let's remind ourselves of our iterative draft result appraisal steps. So for this example, we've made some draft selections, weighting between our middle, closed and reported chain ladder models. We did some quick checks on those draft results and things look fine. We then checked the absolute results and things all look fine with broadly equal ultimate across origin periods. We also felt that our volume 4 models were the most appropriate to use. We checked our standardised results and saw broadly flat frequency over origin periods with no obvious trends. The only origin period which looked a little odd was 2020, where frequency was a tiny bit high and reported slightly less than 50% developed. I didn't show you the all origins charts for this example, in that they all look fine with closed and reported both trending to ultimate. In fact, let's assume that the closed trends look very stable, as we saw for paid claims, and so I'm confident to include the closed model in a few more origin periods. The reported development was unstable only in the first development period, i.e. impacting 2020 again. We only looked at 2015, but let's assume that we checked all the single origin charts, and they all look fine with closed and reported trending to ultimate, and no odd IBNR or reserve figures. If the result had passed all the tests, then we would have saved it down as draft and moved on to the final result setting process. Instead, for this segment, we're going to make a few tweaks, and then repeat the checking process to see if we are more happy with our results. If not, we could of course go back to our original set of draft results. So we go to step 1 and reassess our weightings. I want to stick with my volume 4 models, but I want to include the closed chain ladder model for a few more origin periods, using it now for 2018 and 2019. I'm slightly uncomfortable doing this, as the closed is so long-tailed, only 60% developed for 2019, but want to see how the results fare in this new set of checks. Lastly, we saw that 2020 looked a little high on the standardised results, but as we can see, there is no suitable model to replace it. Given this and the fact that it's a little long-tailed, 49% developed, we will only be able to deal with this in the final results selection process by fixing or using another method. So we won't make any changes to our draft results for 2020. So we now have a slightly honed draft result selection, which we can go through our checking steps on again. There is naturally a law of diminishing returns going on here, so we don't want to keep making tiny changes and have to be careful not to over-engineer our selections. I won't go through the checklist again, as you get the idea. Instead, let's set out our steps to final results. So step 1 is everything we covered in this video, picking a draft result and then checking it. We keep repeating this, honing each time until we're happy. We were pretty close with our first attempt in our example, and almost certainly would have been happy after our second sweep through the steps. We then assess where we think the chain ladder method may not be appropriate. In our example, it looked like the 2020 origin year might be on the cusp of being outside the scope of the chain ladder method, with closed and reported being quite undeveloped. Next, we save down our draft results, and this may well be our final position if we think the chain ladder method is appropriate for all origin periods. Then we ensure we've documented everything in our modelling notes, particularly material issues and assumptions we've encountered in our modelling journey and which we think we'll need to discuss with the reviewer. And lastly, we're going to set our final results where the chain ladder method is not appropriate, so the 2020 origin year in our example, where we'll decide whether to fix or to use an alternative reserving method. I'll cover that decision and how to fix in the next video. So hopefully you can now see how we go about bringing the various chain ladder models available to us into a single draft result for each origin period. We're not quite done, as there may be some origin periods where we're not comfortable the chain ladder method is appropriate, and so we need to do some fixing or use some alternative actuarial reserving methods. I'll cover setting final results in the next video in this series, including fixing and when to know another actuarial reserving method is required. as well as some final checks on our work. You should be able to see the next video in the series on the left hand side here, so please click to move on to it now. As usual, please also like and subscribe to support these videos. Again, you should be able to see a small circle which you can click to subscribe. And do let me know your comments and feedback on these videos in the comments section below. Thank you.